We're going to want to use the same rounding and estimating techniques we learned on whole numbers on decimals. And remember what decimal numbers look like and the various digits. A decimal number is really two parts. It's the whole number portion that works its way from right to left with ones digits, tens digits, hundreds digits, they're getting larger, thousands digits, etc. And then there's the fractional part or decimal portion on the other side of the decimal point that goes from left to right. Tenths, hundredths, thousandths, etc. Now, when we rounded whole numbers, remember how to round? Let's round, for instance, just this whole number, 568, to the nearest 10. Now, to the nearest 10, we're going to have to find the 10 spot. There it is. That means everything after that is going to be a 0. So we're either going to have 560, the same digit for the tens, or 570, the next larger one. We never go down. Now, how are we going to decide? We use the next digit. The next digit is 8, and that's more than halfway, so we're going to go up. The answer is going to be 570. Let's do another. We're going to round this number to the nearest 1,000. Find the thousands digit, and everything else after that is going to have to be a 0. So it's either going to be 267,000 or 268,000. We use the next digit to decide. Now 3 is halfway, well, it's not quite halfway, so we're going to stay the same. We never go down. So the answer, rounded to the nearest 1,000, is 267,000. Now let's do the same thing with decimals. Just have to know our digits. We're going to round this number to the nearest tenth. Now remember where the tenths is. That means everything after that is going to be a 0. There's one little difference here is, in decimals, if everything after it is a 0, basically, when you can, drop it. You don't even, so everything after it is going to go away, is what's going to happen. Okay? So this number is either going to be 156 and 8 tenths, with everything gone away, or 156 and 9 tenths, with everything else after that gone away. What are we going to use to decide? Still going to use the next digit. You're 2. So you know in this case, you're just going to stay the same. 156 and 8 tenths. Okay, let's round this number to the nearest hundredth. That's very commonly done in when we're working with money, because hundredths is cents. There's your hundredths digit. So it's either going to be 267 and 36 100ths or 267 and 37 100ths. Still going to use that next digit, which didn't get halfway, so we're going to use the lower number. We're never going to go down, we're just going to stay the same. Now here's an interesting one.
Excuse me, Professor Brainiac.
This one they want us to round to the nearest whole number. To the nearest whole number means I'm going to round to the nearest ones. That's all. Remember where the ones digit is. So basically that means get rid of the decimal portion. But I'm going to do the same thing. I'm just going to round to the nearest ones digit. So it's either going to be 2,673 or 2,674. Everything else is the same. We're still going to use the next digit. And we know with 6 that we go up. So that's your answer, rounded to the nearest whole, or to the nearest ones digit. You'll do that in science when you're dealing with living things. We can't have a half a person in reality. Okay, now let's use this estimation to make this problem easier. We don't want to make more work for ourselves. We want to make it easier.
I can do that, but I don't want to.
I want you to add these numbers up, but I don't want you to add them up and do all the work and then round. That would just add to your work. The idea is to round first and then make your answer easier to find. 29.4 to the nearest whole rounds to 29, easier to deal with. 6.13 to the nearest whole rounds to 6. And 16.71 to the nearest whole. Of course, the 7 says to go up, so it's going to round to 17. Now we've made our problem easier, and our estimated sum is 52. Actually, the answer is 52.24.
Missed it by that much.
So we did pretty good. Just remember, we use rounding to make life easier, not harder. And we can also use it to kind of check our answers. Oh, we can do it very easily. You'll care about this. When we multiply these two, a lot of people get the right digits. They get 2 3s and an 8. But typically an error that they would make is to put the decimal place in the wrong place. Which of these answers is a reasonable answer? We don't even have to multiply to find that out. We can just round. 1.3 is about 1 to the nearest whole, and 2.6 is about 3 to the nearest whole. So it should be, the answer should be about 1 times 3. Very easy to do, isn't it? The answer should be about 3. Well, looking down at your possibilities, it's not that one. Can't be this one. It's got to be about 3. So I actually got the answer without even doing the multiplication. Now let's actually do this just for the sake of checking. Remember how to multiply decimals? Well, we pretend that the decimal place isn't there and do our multiplication. 3 times 6 is 18. Carry the 1. 3 times 2 is 6, and 1 more is 7. Then 1 times 26. 1 times 6 is 6, and 1 times 2 is 2. We add those partial products. Carry the 1. And then we take that number, and this is what people screw up. We count the number of decimal digits in the original problem, there's 2, and move over from the right that many places. But you knew that. The answer is 3.38, or 3 38/100ths. Okay, so use this rounding to check your answers, or at least make sure that they're in the right range. Go do it. Do your homework.